All right, let's take a look at Unit 6, Lesson 2, Revisiting Right Triangles. So what do you notice and what do you wonder here? I notice that it's a right triangle. It's inside a circle. It's not inscribed in the circle because not all of the vertices of the triangle are on the circle. It has a hypotenuse that's length is C, not 6, C. It also looks like A is shorter than B, but we might not know that for sure. It also looks like angle A is smaller than angle B. We could use the Pythagorean theorem to solve for some of the sides. Hopefully we remember that the angles of a triangle add up to 180. So if angle C is already 90, then angle A plus angle B has to be 90 also, which means they are complementary. So the measure of angle A plus the measure of angle B is equal to 90 degrees. That will come in handy later. I wonder if A is in the center of the circle. Can't really tell. I also wonder what are the measures of those angles A and B, and what are the measures of the sides. All right, let's take a look at 2.2. Recalling right triangle trigonometry. So hopefully we remember this from geometry. Find cosine of A, sine of A, and tangent of A for triangle ABC. So let's refresh our memories. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. You may remember so, ka, toa. And depending on who you had, they might have written it a little bit differently. So we are going to find, and this is our angle of focus. We are focusing on this angle. So this 15 is the adjacent side. The 8 is the opposite side, and the 17 is the hypotenuse. That's always going to be the hypotenuse because it's across from the right angle. If we were focusing on angle C, then the adjacent and the opposite would switch. All right, so cosine of A is the adjacent, which is 15, over the hypotenuse, which is 17, and that's all you have to do. Sine of A is the opposite, which is 8, over the hypotenuse, which is 17. And then tangent of A is opposite, which is 8, over adjacent, which is 15. All right, sketch a triangle DEF where sine of D is equal to cosine of D. So thinking about our ratios, if the sine of D is equal to the cosine of D, and they're both ratios over hypotenuse, like a side over the hypotenuse, that's not going to change. So that means that the opposite side has to be the same as the adjacent side in order for those two ratios to be the same. So what kind of triangle would that have to be? That would have to be an equilateral, not an equilateral, an isosceles right triangle. So those two sides have to be the same. So E, they said, was the right angle. So this can be D and this can be F. It really doesn't matter. So then what is the tangent value of D for this triangle? So let's say this is X. Well, if that's X, then this also has to be X, and we'll call this Y. Actually, no. We're not going to do that. We're going to name them with their letters. All right, so this is F, this is E, and no, this is D, and this is E, right? But we know that D is equal to F. Right? Those two sides are congruent. So we can substitute. So the sine of D, well, actually, we don't need to do that. All right, so we know that D is equal to F. So the tangent of D is equal to the opposite, which is D, over the adjacent, which is F. But we also know that D is equal to F, so we can replace that D with an F. So F over F, so it equals 1. So the tangent of D is equal to 1. All right. Um, let's take a look at, and that's going to be true for any right triangle that is isosceles, because you're always going to have those two sides are congruent, because that's the definition of isosceles. All right, so let's take a look at number 3. If the coordinates of point I are 9, 12, what is the value of cosine of G and sine of G and tangent of G for triangle GHI? Okay, so we said that this is 9, 12. Okay, so that means that this height is 12. This side length is 9, and then we need to find our hypotenuse. So 9 squared plus 12 squared is equal to the radius squared. So that's 81 plus 144 equals r squared. That's going to be 225 is equal to r squared. And then when we take the square root, again, we just want the positive because you can't have a negative radius. If it was an x or a y value, then we might need a negative. And so the square root of 225 is 15. So we know that's 15. So now our cosine of G, and remember G is this angle right here. So this is the adjacent side, and this is the opposite side, and the hypotenuse is always across from the right angle. All right, so cosine is adjacent over hypotenuse, so 9 over 15. Sine of G is opposite, which is 12, over adjacent, which is 15. And tangent of G is opposite, which is 12, over adjacent, which is 9. All right, let's take a look at 2.3. Shrinking triangles. What are cosine of D, sine of D, and tangent of D? All right, so we know that this is 12 units. This is 5 units. And so we need to find our hypotenuse in order to find those values. So 5 squared plus 12 squared equals hypotenuse squared. So that's 25 plus 144 equals the hypotenuse squared. So that means 169 is equal to hypotenuse squared. And when we take the square root, again, we only need the positive because we're talking about the hypotenuse. So that is 13. If we were talking about the x or the y value, we might need a negative. Okay, and we are looking at D as our angle of reference. That's over here. So 12 is our adjacent side, and 5 is our opposite side. So the cosine of D is equal to 12 over 13, adjacent over hypotenuse. I didn't write that down. We'll write that down. Sine of D is opposite, which is 5, over hypotenuse, which was 13. And tangent of D is equal to opposite, which is 5, over adjacent, which is 12. All right, number 2, we have a similar triangle to DEF, right? So similar in the true sense of the word, the geometric sense of the word, similar, meaning that they have the same angles and their sides are proportional. And so we have, we want to find the scale factor. So we see that this bottom leg is 36. The shorter leg is 15. So what could we multiply 12 by? 12 times what is 36? Or 5 times what is 15? Oops, equals 15. And those have to be the same value, right? In order for us to get a scale factor, in order for it to actually be similar, those two multipliers have to be the same. And hopefully we can see that the answer is 3, right? So what does that mean our hypotenuse is going to be? Well, we're going to take our 13 and multiply by that scale factor, and we get 39. So we know that our hypotenuse is 39. All right, I'm going to label that hypotenuse. And so we are looking at the cosine of D prime. So again, we're looking at this angle. So this is our adjacent, and then this is our opposite. All right, so the cosine of D prime is the adjacent, which is 36, over hypotenuse, which is 39. Sine of D prime is opposite, which is 15 over 39, because that was the hypotenuse. And then tangent of d prime is opposite, which is 15 over adjacent, which was 36. All right, let's take a look at number 3. Here's another triangle similar to triangle DEF. And so this one is D prime, E prime, F prime. So this was D double prime, E double prime, F double prime. Let's see. E was that base one. So this one is E double prime. And this one is F double prime. Okay. So part B, what is the scale factor from triangle DEF to triangle D prime, E prime, F prime? All right, so they don't have E and F labeled, but we do know that the length of the hypotenuse is 1. And if we go back up to DEF, that hypotenuse was 13. So 13 times what number is equal to 1? Well, if you divide both sides by 13, you get 1/13. That is ugly. Let me fix that. So 1/13 is our scale factor. Why do I keep doing that? There we go. There's our scale factor. All right, so what are the coordinates of F? So remember that F was 5. Well, I don't want to write that. F was 512. So we want 5 times 1/13, which is 5/13, and 12 times 1/13, which is 12/13. So F double prime is 5/13, 12/13, because we took F, which was 5 and 12, and we multiplied by that scale factor of 1/13. So then what are the cosine of d prime, the sine of d prime, and the tangent of d prime? So if your x value is 5/13, then that's what this is. No, I have those backwards. So let's rewrite that. That was 12, and that was 5. So this is 12, and this is 5. 12 and 5. This was 12 and 5, and I think I need to fix that up here too, yeah. So they were 12 and 5, yeah, because the shorter side was the y value. All right, so our cosine of d prime is, this was, let's go back up here. Our x value was 12/13, and our y value was 5/13. All right, so our cosine is the adjacent side, which is right here. And there's the opposite, and here's the hypotenuse. All right, so the adjacent side, 12/13, over the hypotenuse, which is 1, so you can just leave that the way it is. The sine of d double prime is 5/13, because that's the opposite side, over the hypotenuse, which is 1, so you can just leave it the way it is. And then tangent of d prime is the opposite, which is 5/13, over the adjacent, which is 12/13. And you can simplify that by making it 5/12, because they both have that 13 as a denominator. So you can, when you divide 5/13 by 12/13, that's the same thing as doing this. 5/13 times the reciprocal, so 13 over 12. And then you can see your 13s cancel, and you're left with 5/12. And so that's how you can find the tangent, so that you don't have fractions within fractions. And then you have your summary if you want to take a look at that.